Okay, so in order to understand the concept of KVL and Wheatstone bridge more properly, we'll try to do one numerical on it. Here what we can see, a cell of 6 volt EMF and internal resistance 0.4 ohm is connected across a Wheatstone bridge having resistance 2 ohm, 4 ohm, 3 ohm and 6 ohm. Okay, now since we can see in the question that the Wheatstone bridge is balanced, how we need identify this that the Wheatstone bridge is balanced? Because the ratio of the resistance in the two arms is equal to the ratio of the resistance in the remaining two arms. So 2 upon 4 is equals to 3 upon 6. 2 upon 4, P upon Q. This is P, this is Q, this is R, this is S. P upon Q is equals to R upon S. This was the condition of a balanced Wheatstone bridge. So 2 upon 4 is also 1 by 2, 3 upon 6 is also 1 by 2, means the Wheatstone bridge is balanced and no current will flow through the middle arm, means across the galvanometer, and the galvanometer will show zero deflection. So we can remove the galvanometer from the circuit as no current will flow through it. From the positive terminal of the cell, we'll assume that current I flows. At node A, it will be split into two branches, I1 and I2. Okay, I1 current will pass through the resistance P and Q. I2 current will pass through the resistance R and S. And at point C, again both the currents will combine to form I. I1 and I2 will again combine to form the current I, which will go through the negative electrode of the cell of EMF 6 volt, and this is the internal resistance of the cell 0.4 ohm. Okay, so we'll apply the KVL and we'll try to find out the values of I1 and I2 and I through the KVL. Okay, so in order to apply the KVL, we have to take the loop. We are taking one loop as the loop in which this E, A, D, C, E. First loop as in the loop E, A, D, C, E. D, C, E. We'll take the direction of loop in the direction of the EMF only. Direction of EMF is from negative electrode to positive electrode. Okay. So we'll take the direction of EMF as the direction of loop. So 6 volt. 6 volt will be, now by KVL, sigma E will be equal to sigma IR. Okay, E is 6 volt in this loop. Now currents, 3 resistance are coming in this loop, R, S and this small internal resistance small r. Okay, so in R, I2 current is going, so I2 into 3, direction of loop and direction of current is same, that's why it will be taken as positive. Then moving forward, after R it will have the resistance S. I2 into value of S is 6 ohm. Then moving forward we will get internal resistance 0.4 ohm, जिसमें करंट कैपिटल I जा रहा है, so plus I into 0.4 ohm. Okay, now at node A, what do we see at node A? By KCL, if we apply KCL at node A, so I is splitting into I1 plus I2, so I will be equals to I1 plus I2. Okay, so 6 is equals to 3I2 plus 6I2 plus I can be written as I1 plus I2 into 0.4. 6 is equals to 3I2 plus 6I2 plus 0.4 I1 plus 0.4 I2, or 6 is equals to 3 plus 6 9, 9 plus 0.4, 0.4 I1 plus 9.4 I2. This is our equation 1. Okay, now in another loop, now we'll take the loop as E, A, B, C, E, this entire loop. Okay, E, A, B, C, E. तो इस लूप में बेटा EMF 6 वोल्ट आ रहा है, करेक्ट रेजिस्टर्स P एंड Q आ रहे हैं और इंटरनल रेजिस्टेंस स्मॉल R आ रहा है. So again by KVL, sigma E is equals to sigma IR. Sigma E 6 is equals to I1 into 2 plus I1 into 4. लूप की डायरेक्शन और करंट की डायरेक्शन सेम है, विल बी टेकन एज पॉजिटिव. और फिर आगे आए तो I into small r means I into 0.4. 6 is equals to 2I1 plus 4I1 plus I को लिख सकते हैं I1 plus I2 into 0.4. तो 6 is equals to 6I1 plus 0.4I1 plus 0.4I2. 6 is equals to 6.4I1 plus 0.4I2. So this is how we'll get two equations in terms of I1 and I2 by applying KVL in the two loops. Okay. Now, so first equation of on solving these two equations, we get the values of I1 and I2. First equation is 6 is equals to 0.4 I1 plus 9.4 I2, and 6 is equals to 6.4 I1 plus 0.4 I2. What we'll do, we'll subtract both the equations, first and second. We'll subtract both the equation, first minus second. So on subtraction, sign will get changed, 6 and 6 will get cancelled out. 0 is equals to 0.4 minus 6.4 will be minus 6I1 plus 9.4 minus 0.4 will be 9I2, or we can say 6I1 is equals to 9I2, or I1 is equals to 9 by 6 I2. 3 3s are 3 2s are, it will become 3 upon 2 into I2. We'll put this value of I1 over here. 6 is equals to 0.4. In place of I1 we can write 3 upon 2 I2 plus 9.4 I2. 6 is equals to 2 into 0.2. So 3 into 0.2 will be 0.6 I2 plus 9.4 I2. Or 6 is equals to 0.6 plus 9.4 will become 10 I2. Or I2 will be equals to 6 by 10. 2 3s are 2 5s are. I2 will be equals to 3 upon 5 ampere. I1 from here will be equals to 3 by 2 of I2. So 3 by 2 into I1 was 3 upon 5. So it will become 3 3s are 9 upon 10 ampere. Okay. Or it will can convert it to decimal. I2 will be equals to 0.6 ampere. I1 will be equals to 0.9 ampere. I is equals to I1 plus I2 means 0.6 plus 0.9 plus 0.6, which will be equals to 1.5 ampere. So this is the value of the three currents I, I1 and I2, which we have solved using the concept of KVL and balanced Wheatstone bridge. Try more numericals on the concept, and if you have any doubt in any of the numerical of KCL and KVL or Wheatstone bridge, you can leave a message to me in the comment box. In case if you have any doubt, any query related to the topic, you can go through the concept and you can leave the message. Share this video, subscribe to my channel, and stay tuned for more updates.